Okay, so we'll see this thing now. So, so in our discussion, we will study about first quadrant chopper, second quadrant chopper, and fourth quadrant chopper. So these are the three types of choppers we will study. Okay, so we will take first quadrant chopper. First quadrant type chopper. Now, circuit diagram. The last class circuit diagram itself we will use here because that one was the first quadrant type chopper. So you have a switch, you have a diode, then you have a load here. So you know the load here is the DC motor. So obviously the armature of any DC motor, what do you find out in the armature of any DC motor? You will find out armature resistance, armature inductance, and back EMF EB. This you will find out in every armature of the every DC motor. In the armature of every DC motor, you will find out this armature resistance, armature inductance, and the back EMF. Of course, you know this back EMF it depends on the speed of the motor. Okay, so whereas the supply voltage I will take here, in the supply voltage DC, I will take this as EA. I will take this as EA, and this is the switch here. Okay, so you close the switch, then what will happen? You open the switch, what will happen? This is the thing. I hope you can understand this operation because last class itself I have explained that when I close the switch here. So let me on the switch. Switch is on. When the switch is on, what is the circuit diagram? It becomes the switch is closed, so the diode becomes reverse bias because negative voltage is applied across your diode, so the diode becomes reverse bias. Then what is the circuit diagram? It becomes the circuit diagram. It becomes like this. See the circuit diagram: EA, EB, this is RA, this is LV. So we will apply KVL in this closed part. Okay, let me take the current as IA. Then what is the KVL equation we will find out here. So now this is what switch is on. So now I would like to draw here. We will take the output voltage E naught. E naught is the output voltage. Here I will take across the diode. So I will draw the waveform of E naught with respect to time. So this is time. This is time. Let me take this time as T on. That is from 0 to T on, the switch is on. So when the switch is on, what is E naught? When the switch is on, the E naught is nothing but the same as the EA. So it is same as EA. It's same as EA. Till T on is EA. I will write this as EA. EA is the supply voltage. Okay, so E naught is equal to EA till this time. So when the switch is on, E naught is equal to EA. This we got. What is the current then? The current in the sense this current. This is IA or I naught you will get. So what is the current here? The current will be you will get from this closed path. You will get from this closed path. So if you apply KVL in this closed path, what is the equation you will get here? EA is equal RA IA plus LA BIA by dt plus EB. This is the equation you will get now. So if you solve this equation, if you solve this equation, now of course we will solve the equation also. But if we solve this equation, what is the shape of the waveform you will get here? What is the shape of IA you will find out? Because this is a first order differential equation, you see very well. Okay, for the first order differential equation, what is the solution you will get generally? Exponential. You can even solve several times this first order differential equation. So when you solve the first order differential equation, the solution is always exponential because now RA is there, you have LA is there. So some resistance is there, inductance is also there. Of course, this back EMF is there, so that you can consider as a DC itself. So after all this, what you find out is that you will get that it's exponential. You will find out exponential. Okay. So the current waveform, briefly I will draw here. Okay, or here itself I will draw. The current waveform will be something like this. It will be exponentially rising like this. Yes, like this. It rises like this. It rises like this. Okay, because this I will write IA here. Of course, we will solve IA also here. There is no problem with this. So how to solve this is that we will do one thing. We will take this EB towards left hand side. Okay, then EA minus EB is equal RA plus LA by DB. Okay. So either you go for the differential equation approach or you go for the Laplace transform approach. Any one approach you can go, and you will get the solution. No problem. So right now I will use the Laplace transform here. So if I use the Laplace transform, what do you find out here? EA minus EB by S, because EA minus EB is a constant value. So the Laplace transform for the constant is 1 by S, or that constant divided by S. That's Laplace transform. Okay. So then what we get at this side? RA IA of S. Okay. RA IA of S plus LA S into IA of S minus its initial value. So I will write the initial value. I will tell you. I will give a name to that IA minimum. Or see this, instead of A, you can take IA or I not, no problem. So IA minimum. I will write minimum. I will tell you why it is minimum. So this is the initial value. So when you take the Laplace transform to differential, you will get S into IA of S minus its initial value. I am saying the initial value here is IA minimum. Generally, what is the initial value function here? Zero is the initial value function. But we are taking the steady state case. Steady state case in the sense, and let me take the case of continuous conduction mode. Say for example, if I take the continuous conduction mode and that in the steady state, what is the waveform you will get now? Which kind of shape you will get the waveform here? Because see here, what is the shape you will get here? So to understand the shape here, I will tell you why I have taken IA minimum. So before we go why I have taken IA minimum, let me take when the switch is off, what will happen? When the switch is off, what will happen? Switch is off. So what will happen when the switch is off? Just see this. When the switch is off, what is circuit diagram? When the switch is off, now this inductor will force the diode to conduct. So the diode becomes forward bias. So when the diode becomes forward bias, so what is the circuit diagram it becomes now? So something like this it becomes. The diode is the forward bias. So the R is there. Okay. RA, LA, EB. This you will find out. Okay. And so the current here is now IA. Okay. Now what is E naught in this case here, because I have taken E naught at these 2 points, this point and this point I have taken E naught because this is the armature circuit diagram. This RA, LA is armature diagram. So the input to the armature circuit diagram, I am taking it as output of the chopper. So E naught. So what is E naught in this case? In this case, E naught is 0. You just see yourself, because the diode is forward bias, so it is short circuit here. Okay, so if it is short circuit, then obviously what we find out is that so obviously we'll find out the situation. EA is equal to 0. So when EA is equal to 0, now you see yourself now. What is the equation you will get in this case? In this case, what is the equation is that RA, EA plus LA DIA by dt plus EB is equal to 0. Now, if you solve, what is IA? This time also IA is exponential. Why it is IA exponential? Because this is also, what do you find out? This is also a first order differential equation. Definitely it is exponential. Now what is the difference between the exponential which you got here when the switch is on? What is the difference between the exponential which? This case it is exponentially rising. I will write here rising. Exponentially rising. Okay. Whereas this is exponentially decaying because you see the output voltage is E naught is zero. When E naught is zero, then there is no source here. Whereas the first case there is a source, that is EA is there. There is source is there. Here there is no source is there. So exponentially decaying, exponentially rising. So, but what about it? So then if I can draw the waveform of EA here, that is output voltage E naught, then after T on, the voltage becomes, output voltage becomes zero because the diode is forward bias. So the diode is forward bias, so it is zero. So I will take this as total time T. So from T on to T, what is the current waveform? The current waveform is also exponential, but it is decaying. So if it is decaying, how the shape will be? Something like this. Yeah, this shape will be. Okay, now this is during starting. This is during starting. So for example, it's a continuous conduction. Now, when I take the steady state part, then what is the current waveform? The current waveform is something like this: rising, falling, rising, falling. So now this one, this point, it is not zero. Let me tell you. Here it is also not zero. So it is also not zero. So it is falling, rising, falling, rising. So when it is doing falling, rising, except the first part where it starts from zero, after that in the steady state, what you find out is that it will never become zero because it's a continuous conduction. If you take, it will never become zero. So it will have some value of this. The minimum value is this, maximum value is this. I will take this as IA maximum. This point as IA maximum, whereas this point as IA minimum. So now you see when it is rising, what is its initial value? IA minimum. When it is falling, what is its initial value? IA maximum. Okay, so see here I will draw the current waveform once again here. In the steady state part I will draw. Okay, so rising, falling, rising, falling. So now this is T on. This point is T on, whereas this is total time T. Okay, so now this current, this current, and this current, these three currents, what are these values? In steady state I am taking it as IA minimum, whereas these peak values are there, this one. Okay, this I am taking it as IA maximum. So when I want to solve this equation, when I want to solve the equation for this part, rising part, what is its initial value? IA minimum. When I want to solve the falling part, what is its initial value? IA maximum. That is the reason I put here IA minimum. I hope you can understand this. That when you take the Laplace transform of it, first order differential, it is s into IA, s into that function, that is Laplace transform of that function minus its initial value. What is its initial value? Its initial value is IA minimum for the rising case, whereas its initial value is IA maximum for the falling part. So for the falling part, it is IA maximum, whereas for the rising part, it is IA minimum. These are the initial values. So now, once we understand this thing, that which is minimum value, which is maximum value, okay, in which case we got the initial value. So then what you will understand here is that few things you must understand now. So we got one equation here. So we stop there itself. Okay. Similarly, when we take, I want to solve this second case also. That is when the switch is off. What is the in this case? What is the Laplace transform we will get is that, yeah, RA IA of S plus LA into S IA of S minus, I will write this term as IA max, because for this part, which part? For this part, what is the initial value? IA max, whereas for this part, what is the initial value? IA minimum. So likewise I will use that, then plus EV by S is equal to 0. So these are the equations you will get here. Okay, so these are the equations you will get here. So this equation is for when the switch is off, whereas this equation is when the switch is on. So we got the Laplace transform equations. Then what's next we are going to do is that we will solve these equations. Okay, first we will solve the first equation. This is the first equation I will take. This is the second equation. So first equation, second equation, what's the difference? First equation is when switch is on. That is the output voltage is EA. E naught is equal to EA. whereas the current is exponentially rising, and its initial value I have taken it as IA minimum. Coming to the second equation is when the switch is off. When the switch is off, the diode is powered back, so the output voltage E naught is equal to 0. Okay, and the current is also exponential, but it is decaying. So when it is decaying, in that case, you will get this equation, and in that the initial value is IA maximum. Okay, so we divided the current function of the current equation in two parts: when the switch is on, when the switch is off. So two parts we will find out individually. We will solve individually. Just let me take the first part, that is this one. Okay, uh, this first equation will start here. Okay, okay. If you solve this, what we will get? We will see now. Okay, so how do you solve this now? How do you solve this equation? So from this equation, what is IA of this? We will get. Yeah, here you have AFS. Here you have AFS. We will take common. Then we will get something like this. So EA minus EB by S into RA plus SLA. Yeah, this you will get. Okay. Plus, I hope you will get plus only because this minus here, so the minus related to left hand side, it becomes plus. So IA, LA, IA minimum whole divided by, okay, whole divided by RA plus SLA. Yeah, we'll get this equation. So IA of S we got. Okay. Then how do you find out IA of T? IA of T is nothing but inverse Laplace transform of IA of S. Okay. So we need to take the inverse Laplace transform of this. Okay. Then we will get the solution for that. Okay. So I would like to. I have done that already. Okay. This one I have done already. So you got. Um, I would like to write this here directly. I will write this here. So when we take the inverse Laplace transform, so I hope I have done this kind of inverse Laplace transform even in the previous topics also, that we can take the inverse Laplace transform of this, by going for partial fractions and so on. Some kind of mathematics will take the help and we will do that. I have done that already, so I will just write this expression of inverse Laplace transform directly. So you can cross check that. Okay, I do not doubt in this. Then what is the answer you will get here is that I will get the solution directly here. EA minus EB by R RA to into 1 minus E power minus RA by LA into T. Okay, plus minimum minimum into E power minus RA by LA into T. See, remember, this one is for which case? This is when 0 less than or equal to T less than or equal to T on. That is during on time only. This equation which we got here for IA of T, it is during on time. So now we can rewrite this equation further. How we rewrite this equation is that IA of T is equal, IA of T is equal. So I will write here IA of T is equal EA minus EB by RA minus E power minus. See here, we can take this as time constant tau is equal LA by RA. I will take this as time constant. So in that case, what we will get here? E power minus T by tau. Okay, plus IA minimum E power minus T by tau. This is the equation of IA. we have t, we got the equation. Okay. So where tau is nothing, what is the tau here? Tau is the time constant. So time constant, we are taking it as LA by RA. So that we know. That's series RL circuit, I hope you know what is time constant. Okay. So now, one important thing you will get from this. What is the important thing? Let me go to the equation here. Yeah, you see now. This is at t is equal to 0. We start at t is equal to 0. So now till t on, it is exponentially rising. Till which point it will rise? It will rise to Ia max. That's very important. So it means when t is equal t on, when t is equal t on, what is Ia value? What is Ia when t is equal to t on? It is nothing but Ia max. So that point we will consider here. What is that point considered is that when t is equal to t on, Ia of t is equal Ia max. This value will get it. So we will substitute this in the previous equation. Then what we will get here is that Ia max value. Ia max is equal EA minus EB by RA into 1 minus e power minus t is equal to t on we have taken, so t on by tau plus Ia minimum into e power minus t on by t. This we will get here. Okay. So this is one of the important equation. We will take the help of this equation later also. So we will consider this as equation number 3. So now what you must understand here is that this equation has Ia minimum and also Ia maximum. This is important. Okay, we will take this some other. We will take this equation in some other form. Okay. So next, what we do is now this during half time there is one equation we got here. Second equation, equation number 2. We will solve this equation number 2 now. Okay. So this is the equation number 2. So we will solve this equation. So now we solve this equation is that from this equation what is Ia plus you will get. Okay. From this equation. Yeah. This is for during half time. It's very important. So during half time, what is the equation we are solving? Ia of s. So what is Ia of s is that minus EB by s into s into s value will be there. So Ia of s, so RA plus SLA. Okay, plus LA Ia max Ia max whole divided by RA plus SLG. IAFS. Okay, so this is the equation you will get for the IAF. Then what is IAF? Same procedure. IAF is equal to inverse Laplace transform of IAFS. So we have to solve this once again. So when we solve this here, I'm going to write directly what will happen when we solve it. Okay, so then we take the Laplace transform, inverse Laplace transform, and we follow the partial differential equation. Then we get one equation. Okay, so that equation I'm going to write directly because that I have done already. So we get minus EB by RA, EB by RA into 1 minus e power minus t by tau. Once again, tau is nothing but LA by RA. Directly I'm writing here plus Ia max e power minus t by tau. Now remember always this is for which duration? This is for t on less than equal to t less than equal to. This is during half time. So half time is from t on to t, it is half time. Okay. So we got the expression for that. So it means this expression. expression, this expression. Yeah. So for this case, okay, we have completed that. So in this case, can I say this thing that when t is equal to capital T, that is when t is equal to total time, t, what is its value here? IA minimum. So we will take the help of this point, that is when t is equal to tau, IA is equal to IA minimum. So we will take this and we'll try to substitute that in this equation. So when you do the substitution here, okay. So what you will get here at the end is that I will write here, because see here we are combining both the equations, both the parts, which both parts now when the switch is on, when the switch is off, both the parts we are combining. So when you do the combination here, and when you substitute this condition, that what is that condition? When t is equal t on, sorry, when t is equal t, that is when t is equal t, when t is equal t, what is IA? IA of t is nothing but IA minimum. We'll take this help and we'll substitute that and we'll see what is the equation we'll get here. So when we do this, okay, one important function we'll get here. What is the function we get here is that I naught minimum, IA minimum is equal, IA minimum is equal, okay, so minus EB by RA into 1 minus C power minus t minus t on, because you see the duration starts from t on itself, not from 0. So it is 0 to t. So what is the difference between these two? So t minus t on. So I hope you can understand this from the mathematical analysis. Okay. Then plus IA max e power minus e power minus t minus t on divided by tau. So this is very important to note that. So this is another equation. Now you see here equation 3 is the equation, this is equation number 4. So it's very important equation. Why it is important equation is that you got one important thing. What is the thing is that if you see equation 3 and equation 4, what you will find out is that in both these equations you have IA minimum, IA maximum. Here also IA minimum, IA maximum is there. So in both equations you have this. So you have two equations and two unknowns. IA minimum, IA maximum are the two unknowns. And you have two equations. So when you solve equation 3 and 4, solving 3 and 4, we can find out IA minimum and IA maximum. This is the logic we will use here. Okay. So solving these two, okay, so we can easily find out what is IA minimum, what is IA maximum. Okay. So after solving this, I'm writing directly. Okay. So because please you can solve that. I have done that solution already. Solving the equation 3 and 4. What I will get directly, I'm writing here. So what I will get here is that IA max is equal EA by RA into 1 minus e power minus T on by tau divided by, see it's only mathematical solution, nothing else is there here, minus T by tau. You try to solve it. If you don't get, you can ask me also. Minus EV by RA. So this is for IA maximum. This is for IA maximum. And what is IA minimum? Similarly, we will get, because you have two equations, you will get two unknowns easily. There is no problem in that. So IA minimum, what you will get IA minimum is that EA by RA e power T on by T on by tau, T on by tau divided by e power T by tau minus EB by RA. Yeah. This is for IA minimum. So we got the equations for IA min maximum and IA minimum. So what exactly we did here, that we have taken the first quadrant chopper here. Then for during switch is on, what is the equation we will get? During switch is off, what is the equation we will get? We got two equations. Then we have solved both the equations. When we solve both the equations and we substitute the values here, what are the values? So at the boundaries we have substituted the values. Then we got two more equations. In those two equations we have IA minimum and IA maximum. So when we solve both these equations, at the end what we get is that we got the expressions for IA maximum and IA minimum. These are the things we got as of now. Okay. So the equations we got as of now. And then we see what's next now. Okay.